Hi class. In this video I'm going to go through all the steps of lab 6 with you. An important point that you should know is that you should go on Learn and download the Biased Resonator 2D Basic, which is the geometry which will be used in this lab. So I've already done that. I have the Biased Resonator 2D Basic on my desktop. We are starting the tasks now. First thing you have to do is go to the model wizard window, click on 2D button, next, and in the add physics tree, select structural mechanics, electromechanics. Click next, and under the study subsection, select preset studies stationary. Finish. Now, going to the next step, we want to have, first we are saving our file as lab 6, let's say. Then for having the geometry, in the model builder window, go to model 1, geometry 1, and go to the settings window for geometry, find the unit section, and change the length unit from meter to micrometer. Now, right-click on Model 1, Geometry 1, and choose Import. Go to the Settings window for Import, and browse, and choose the Biased Resonator 2D. Open, and click the Build All button. Click the Zoom Extents on the Graphics toolbar. The next part is going to the global definitions. We want to add a parameter for the DC bias voltage magnitude on this part. In the model builder, right-click on global definitions and choose parameters. Now, go to the settings window for the parameters and type in VDC and 35 volts under expression. This value is the DC bias voltage, so the description would be DC bias voltage. Now, go to the Model Builder window again, right-click on Model 1 Definitions, and choose Selections and Explicit. Now, from the geometric entity level, we just want domains 5, 6, and 9. So we will choose all the domains, and we're gonna deselect the ones that we want, which are 5, 6, and 9, and remove the other ones from the selection. Now, right-click on Model 1 Definitions Explicit 1, choose Rename, and change the name to Resonator. Click OK. Now we want to create a selection to define the resonator surfaces. Right-click on Definitions, choose Selections, adjacent. Now go to the settings window for the adjacent. Find the input entity section. Under the input selections, click add. Now we can see the add dialog box. In the input selections list, select resonator and OK. Now again, right click on model 1 definitions, adjacent 1 and choose rename. And you can see the dialog box again, type resonator boundaries. And click OK. The next part is creating a selection for the drive electrode. Now right click on definitions, choose selections explicit. So we are repeating the steps that we did before. Now this time we only select domain 8. So again, we are selecting all the domains first and be selecting the one that we are interested in, which is 8. Now right click on model 1 definitions, explicit 2 and choose rename. Now the dialog box is here again. We are typing drive electrode in the new name and click OK. Now we want to have the boundaries for this drive electrode. So right click on definitions, choose selections adjacent. Now in the settings window, locate the input entities again. Under input selection, click add. In the add dialog box, this time select drive electrode and click OK. Now right click on model 1 definitions adjacent to and choose rename. Now in the rename adjacent dialog box, type drive electrode boundaries. And click OK. So as you can see, next part would be taking care of materials. So now we want to add materials to our model. In the model builder window, right click model 1 materials. So just go to model 1 materials and choose open material browser. Locate the materials section, select MEMS semiconductors, polysilicon. Right click and choose add material to model. In the model builder, right click materials and choose open material browser again. And locate the materials section, go to MEMS insulators SiO2, right click and add the material to model. Now we're taking care of SiO2 part. So in the model builder, click model 1 materials SiO2 as we have here. So find SiO2 and select domain 1 only. So what we did was that we defined the materials that we have. Now we are choosing the domains that are related to each of the materials. So again, we're selecting all and deselecting the one that we're interested in and removing the other domains. Now right click on materials and choose Open Material Browser. Again, we're going to the material browser, finding the materials section. We're going to MEMS, insulators, Si3 and 4, silicon nitride. Right click and choose Add Material to Model. Now, the next part is for silicon nitride. In the model builder, right click on, so first we are clicking on model 1 materials, Si3 and 4. So after finding Si3 and 4, select domain 2 only. Selecting all the domains. Selecting the one we're interested in and removing the other domains. Now, right click on materials and choose Open Material Browser again. Now, what we have to do is to, under the materials section, select built-in air and add material to model. Now, we want to dedicate the domains that are related to air. In Model Builder window, click Model 1 Material Air that we can see here and select the domains 3, 4, 7, and 10 only. What we want to do here is to set the air material to be non-solid. So what we should do now is to go to the settings window for material, click to expand the material properties section, and from the domain type list, choose non-solid. Now the next part is the electromechanics part. What we want to do is to set up the solid mechanics and electrostatic boundary conditions. What we are doing is that, again, in Model Builder window, right-click Model 1 Electromechanics and choose Linear Elastic Material Model, which is the first one here. Find the domain selection section and from the selection list, choose Resonator. Now what we want to do is to apply fixed constraint on the base of the resonator electrodes. So in the model builder, right-click Electromechanics and choose the boundary condition, structural and fixed constraint. Something important to note is that we have two structurals. The one that is related to boundary is the second one, so we are interested in the second structural option that you see here, and then fixed constraint. We want the boundaries 18 and 60 only. Again, we are selecting all and deselecting 18 and 60. Now what we want to do is to apply a mesh. So what we are doing is that we are going to Model Builder, right click on Electromechanics, choose the domain setting Deformed Mesh, Fixed Mesh. Now we are choosing the domains 1, 2, and 8 only. And an important point here is that the mesh boundary conditions are suitable, the default ones for this model, so we don't need to add mesh here again. Now, taking care of the electric potential 1. Model builder, electromechanics, choose electric potential. Now, go to the settings part and select boundaries 2 and 42. Select all the boundaries, deselect 2 and 42. And so here we have electric potential 1. Now for the electric potential 2, in the model builder, right-click on electromechanics and choose electric potential again. This time, all the boundaries, select it again and choose resonator. Locate the boundary selection and choose resonator boundaries this time. Again, go to electromechanics, choose electric potential. Go to settings window again, and this time choose drive electrode boundaries. Now, find the electric potential section in the V0 edit field type VDC. So, an important here is that we need to improve the meshing resolution in the narrower gaps that we have. So we want to modify the default mesh settings at this point. Go to the model builder, right click model 1 mesh 1. Choose edit physics induce sequence. Now in the model builder, click model 1 mesh 1 size and go to the settings window for size. After finding the element size section, click the custom button. So here we want to change the values. Locate the element size parameters in the resolution of narrow regions edit type 1.4, so the last part. And click build all button. At this point, our model is ready, and from now on we are starting with the task parts.